right, so our next speaker, I'm just going to say it, Lazar from Century. Give it up, please.
And welcome to the Forensics of RSCs. We're doing some research on RSCs. These are my learnings. And these are the things that I'm kind of excited about, so I wanted to share it with you. Alright, so my name is Lazar Nikolov. I used to be a software engineer, now I'm a developer, advocate, work at Century, focused on web performance, that's why I'm here. I'm based in Toronto. I like to learn new things and immediately teach them to my community, which is what got me into DevRel. If you want to follow me on Twitter, my handle is @NikolovLazar. Creatures.dev is one of my communities. The private Discord server is pretty chill. You should check it out. Alright, so let's get into it. RSCs. RSC stands for React Server Components. And they're this new architecture, new innovation in React's ecosystem that leverages the good parts of client-side rendering and server-side rendering, but it also leverages streaming HTML to deliver the website's contents as fast as possible. And the coolest thing about it is that it significantly minimizes the bundle size. It minimizes the amount of JavaScript that is being sent from the server to the client, and we'll see how. So let's look at the evolution of how we used to render React applications. So ever since day one, we started with client-side rendering. We built our applications, we packaged everything into one heavy bundle and just threw it at the browser with the hope that it knows how to handle, and it did. But the content was loading pretty slow. We were shipping essentially empty HTML, so our SEO wasn't, it was subpar. And we were prone to fetch waterfalls because it's how React is built, right? Componentized, every component fetches its own data, throw in conditional rendering, and that's it. So we needed to fix that, and we started rendering our apps on the server, therefore server-side rendering. So we improved the SEO because we weren't shipping empty HTMLs. The HTML came with data preloaded, so faster content load. The browser had it immediately. The data fetching happened on the server, which is closer to the data source, latency, etc. It's already there. But we actually need a server now. It was fine hosting our apps on a CDN, our CSR apps, but now we actually need a server. Because the server needs to do all that work before it sends the HTML, our time to first byte was hurt, and we know when you touch the time to first byte, the rest of the web vitals, they'll just follow. And the interaction, no interactions until the whole page is hydrated, so we need to wait for hydration as well. From that point on, we branched on into two different flavors of server-side rendering. That is SSG and ISR. So SSG stands for static site generation. It's basically generate all the HTML at build time, grab the static HTML files, put it on a CDN, there you go. Time to first byte fixed, SEO fixed, everything's fixed. It worked effectively for marketing or for blogs. But now we need to rebuild the whole website, even if we just make one change. Okay, for some it works, for some it doesn't. There were more dynamic websites, so there comes ISR, incremental static regeneration. It's basically SSG, but it allows you to rebuild only parts of the website that has new data. For example, the blog page or etc. But what does that mean? We need to have a server. So now we can't just host on CDNs, right? So as you see, up until this point, we pretty much juggled between CSR, SSR, SSG, and ISR, and that only resulted in trade-offs. We improved something, but we made something else worse, right? RSCs, I think, is like the next logical step, or at least a step in the right direction. It allows us to choose the rendering strategy not for whole websites, but on a component level. If this footer that can go static, right? We don't need to like rebuild it every time, etc. So that's the beauty of it. It ships data, the content actually, in the initial HTML. So SEO is good. As I mentioned, it reduces the amount of JavaScript sent because we get to pick which component gets rendered as static. So we're not shipping just throwing JavaScript to the browser, but they still allow us to maintain that interactive dynamism that our users are expecting from our websites. And I think at this point it's been almost a year since RSCs have been released as stable. If I remember correctly, it was Next.js 13.4. And people will start to think about for reals to implement it in their websites, right? It's been 1 year. You've been making mistakes, there's guides on how to do it, etc. So that's why it's important to keep an eye on your performance and on the errors. Especially in times like this when we're actually adopting new technologies. And yeah, Sentry can offer you performance monitoring and error tracking, if you ask me, best in class. It tells you how your releases are performing, and how stable they are, so you know that you made the right decision or you made a mistake jumping the hype train. And yeah, if you want to check it out, sentry.io/4/Next.js, or just go ahead and click on the platforms, you'll see a bunch of them. So let's get into the anatomy of RSCs now. RSCs introduce two new component types. We got client components and server components. And the difference is not functional, but it's actually where they get executed and what gets shipped to the browser. Client components, they're actually nothing new. They're the good old components that we had ever since day one. They handle interactions, they have access to the browser, APIs, their code gets shipped to the browser just like before. They get hydrated, but because in RSCs the default type is a server component, we have to mark them explicitly by the use client directive at the top of the file. And this can be after an import. It has to be at the top of the file. I know comments are okay. You can put comments on top of the directive. But there's nothing else different in client components than what we know so far. Server components are the new thing. All right, so they get executed exclusively on the server. And they also get executed in one go, which makes it so much easier to avoid fetch waterfalls nowadays. And their code is not shipped to the browser, but only the output gets shipped to the browser in static HTML and RSC's payload, which we'll see later. And what does that give us? That gives us like three important things. First, we lose interactions because we only ship HTML, not JavaScript, but that means we don't get to do any hydration, which is good, right? It's safe to use server technologies, like you can see here. I know some people might frown when they see await db.product, etc., and then return HTML. But only the output HTML gets sent to the client, so it's safe to use server technologies like APIs, secrets, and third-party services, etc. But then what's also cool is that large dependencies do not contribute to the bundle size. Just bring in the whole Lodash, generate the HTML, and that's the only thing that's going to be sent, regardless of how big Lodash is. Okay, that is the coolest thing about server components. And now these two have their own interesting relationship, because by default components are server components, and because we explicitly need to say this is a client component, it's natural to think that the whole component tree is going to be server components, unless we really need to handle some user interaction, like an on-click event, or access the browser APIs, or key down, whatever. In that case, we'll just isolate that part of the app into its own component and just make it a client component. And that's true. This is the recommended way by the React team to how we can architect or structure our apps using RSCs. But there's one thing to note, and it's an interesting catch. It's not possible to have a server component under a client component. But there's a catch. You can pass it in through the children prop, and it's going to work nicely. But if you import it, like import component from yada yada yada, then it becomes a client component. So if you have any API secrets, etc., in that component, they'll just get leaked to the browser. The compiler is not going to yield to you. They'll just convert it into a client component and ship the whole thing into the browser. So you either leak like secrets and stuff, or most likely you'll just get an error saying, what the hell is DB dot? Because the browser doesn't know what the DB is. And that is the only thing that you need to know in terms of client components and how they relate to server components. Just don't import server components into client components. Okay, this is going to be hard now. I realized, yeah. I made this diagram to showcase how and what happens when we visit a page, an RSC's page. Okay, the user gets on the page. In Next.js, we'll try to find the server component that is assigned to the root. And it's going to ask server-side React, please render this component, the page component, and everything under that tree, okay? And then React is going to do this. It's going to go component by component. And based on the type of the component, it's going to do 3 separate things. If it's just a simple server component that is static, it's not pulling any data, it's not waiting on anything, there's no promises, just going to render the HTML and keep it there. If it's a client component, it's going to prepare client component instructions in the form of an RSC's payload, which we'll see later. And it's basically telling the browser, this is a client component, this is the JS file, this is the accompanying CS file, this is how to load it, and this is how to hydrate it. Just instructions to the browser. If it's a suspended server component, most likely we've added it into a suspense boundary. So it's just going to grab the fallback element, but trigger the actual component in the background and move on. So as it goes through the whole component tree, it generates RSC's payload, it generates static HTML, and it just streams that back to the browser. And this is when it happens for the first load, because all of this can be cached, so the next time it probably won't happen, it'll just be streamed directly. But that's when the users are starting to see the content, right? And we're talking about most likely the page shell, any static content that we can see, like navigation, etc. The users are able to navigate and perform HTML native actions like submit forms or navigate links, etc. But then as the components, the suspended components finish loading, they just get streamed back to the clients. And along with the first one, there's an RC function that you'll see later that knows how to swap the fallback with the actual HTML. So that's why we can see that the pages progressively render the content, all right? And in a nutshell, this is what happens. All thanks to the RSC's payload, right? So this is a special data format, and I think this is the second or third iteration so far. Maybe it'll change again, we'll see. But it's a special data format that contains the rendered HTML, and you'll see that in these $sign payloads, the client component placeholders and instructions, again in the same types of payloads, references to resources and files, also called hints, which you can see in the HL, and I'm sorry for the screenshot, but you can see them in the HL payloads. What else we got? Instructions on how to load JS files, the I payloads, and any props passed from the server components to the client components. You don't need to worry about understanding the RSC's payload. It's just a matter of, okay, I know what the RSC's payload is, I know that it contains some instructions. It's basically the server telling the browser, do this now, right? Again, I'm sorry for this. I thought it was going to be different, but this is a page. I can share the slides later so you guys can see. But this is what the browser sees. Let me try this. Let me try to zoom in somehow. What I did was invoke curl with -d --row and save that to a file. And this is basically going to localhost 3000 and just putting everything that the browser receives, the whole data, right? First we got the headers. It's important to see that the transfer encoding response header is set to chunked. What that means is that the server is telling the browser, I'm going to send you the document, but it's not going to be like a single data transfer. Don't close the connection, all right? I'm going to send it to you in multiple chunks, right? So don't close the connection, you'll receive more data. And then you start to see all of the chunks. And the chunks are in two lines. First, it's the size of the chunk, and then we got the actual content of the chunk. And check this out. The first chunk is the doc type declaration. And that's the top of our document, right? The one at the bottom, the last one, is closing the body and HTML. And that is the bottom of our document. And this all happens across the span of several seconds, right? So this gives us the idea that the document gets sent gradually. The closing of the body and HTML tags is the last thing that the browser receives before it cuts the connection. But the browser is still able to paint everything. And thanks to guys that work in Mozilla and Chrome, our browsers are fault tolerant. Even though they haven't received the closing, like the full document in entirety, they can still paint whatever data and content they have. That is basically HTML streaming in a nutshell, right? That's how we can make this work. And now you see the _next.push. These are all the payloads. So in the first chunk, we have the whole page shell, all of the static HTML. And then after that point, the browser is going to paint everything, but then it only receives instructions. Replace this placeholder with an actual HTML, or pull in this file, or load this JavaScript module, etc. In the red box here, we got the chunks that belongs to the first suspended component, and these two arrived 5 seconds later after these arrived. Okay, and this one contains the HTML to the children prop here, the HTML of the suspended component, and it also contains the RC function that knows how to swap out the spinner with the actual HTML, right? And then we have the more payload at the, after that one, and at the end we have a zero-sized chunk that indicates this is the end of the communication. I have nothing else to send to you. Just feel free to cut the connection. And that's basically what the browser sees across the span of several seconds. We're going to try to see this through through a timeline and how everything happens. Okay. So at the start, sorry for the font, etc. At the start, we see a bunch of resources like fonts and CSS being pulled here. And that's because they're part of the initial HTML. The browser is aware of them, so I'll just start bringing it in. There's a parse HTML span that tells us that there's HTML incoming to the browser, so the browser will parse it before doing anything else, right? Fast forward a few hundred milliseconds, we'll see some JavaScript scripts start being loaded. There's a hydration block over here that needs to happen for us in order to see the page. And then we see the first frame after all of these things. And this is Next.js in dev mode, so it should be faster if we run it in production. And also the LCP and FCP are set here because that's how my demo app was built. But 5 seconds later, over here, we can see another parse HTML. That means we received some chunks of HTML, the browser parses it, and what happens after parsing the HTML? we get to see how the browser pulls in additional JavaScript and CSS resources. And this is a lazy loaded client component that needs to be fetched additionally. So these were not part of the initial page load, so the page can load much faster, but they can get pulled in when their time or when they're needed, right? And then at the end we see that the DCL event is here, which probably means that the server streamed a zero-sized chunk. That is the end of the connection, and there we go. Yes, this is the main HTML. This is the main HTML request, and it ends there. So that's basically how the page loads, right? We get some chunks, we parse the chunks. The chunks may contain things like, hey, pull in these resources, etc. But we get to start painting the website a lot earlier in the process. I took the time to refactor the app into traditional SSR just so we can see them side by side. And these are Sentry screenshots. On the left side we have the traditional SSR. On the right side we have the RSCs. And the differences are day and night. So the web vitals for the traditional SSR, they're all 4+ seconds, right? Because that's how much time the server needed to gather all the data and send the HTML to the browser. So everything else happens after the 4th second. Therefore, you can see the resources start to load after the response is received to the browser. This is from the browser's perspective, right? But on the other hand, we see that on the RSCs, the web vitals are significantly lower. Why? Because even though the request is like 3 seconds plus, the response starts a lot earlier. And that's when the browser gets that initial HTML. It discovers all of the resources, like all the CSS and fonts and JS, etc. And it starts to pull them in, and it's able to start painting the whole page a lot earlier. It doesn't need to wait all the way to the end. And I forgot to highlight that, but at the end here, we got a couple more resources here, which are at the very end. And this is the lazy loaded client component. And you'll see where it gets loaded. So, yeah, the differences are huge between traditional SSR and RSAs. And in a way, it is SSR, but you get to paint a lot earlier during the process. So, in conclusion, it's a new architecture that leverages the good parts of client-side rendering and server-side rendering and implements streaming so it can stream the data and the content that it already has to the browser, so the browser can start painting and fetching resources a lot earlier. It introduces 2 new components, server components and client components, which we are able to pick what gets executed on the server and what gets executed in the browser, in the client. It does have its own challenges. One thing that comes to my mind is state. Right now the state is split into 2. It's not even state, we can't even call it state in the server component because it's not persisted. But the clients have their own states, and these 2 the server cannot access the client state, etc. Yeah, it has its own challenges, but we can see overall significant improvements when it comes to rendering the pages. So yeah, thank you. If you want to check out Sentry, there's a sandbox on this link. We're also doing a web performance meetup next week, next Wednesday. If you're still in town, jump in, you can check out the details on this link. And we can get into questions. If you don't think of a question now, but think of a question tomorrow, just tweet me.
Merci beaucoup, monsieur.